So the second part of the topic on inverse functions starts off with graphing them. And there's a theorem here that says that the graph of the function f and of its inverse f of x are symmetric with respect to any line or the line y equals x. So the line y equals x is in here. All right, so if we think about reflecting a point across that line, okay, perpendicular to and same distance from the line, we get the inverse of that point on the graph. And if we look at the coordinates, this point right here has coordinates a1, b1, and down here the coordinates are b1, a1. Okay, likewise up here a2, b2, and down here the reflection or the inverse of that point would be b2, a2. So really what's happening here is when you graph the inverse of a function, essentially you're just switching the x and y values. All right, so really all you have to do when you're graphing, aside from reflecting it over the line, if you just need to get the points, then you just switch those x and y values. And I have another diagram that I created down here where I drew a graph and I have 3 points and I have a table that are labeling the 3 points here. And this is, let's say, is my function f of x. Now if I wanted to graph the inverse function of x, what I'm going to do is just reverse those values. So the inverse function of this point would be 2, -3, and the coordinates of this point would be -1, 2, and then 0, 4. And if I graph those points, over 2 down 3 is about right here. And if I were to, let's draw in the line y equals x, just that diagonal line here. And if I look at these, this point reflected across the y equals x line, you can see that they're the reflection over that line. All right, so how about the point -1, 2? Over -1, up 2, here's this point, and we can see that it reflects over that line of symmetry. Over 0, up 4, here's 4, 0, 0, 4 is here, and if I just kind of compare and compare them over the y equals x line, we can see that it is the reflection. All right, so again, to get a point or a set of points and the inverse of them, you're just switching the x and y values. And remember that this is the domain and this is the range, and in my inverse function, the range becomes the domain and the domain becomes the range. So that's kind of helpful in this next section that we're going to look at, and it's asking us to find the inverse of a function. All right, so basically what we need to do is take the y equals f of x and interchange the variables x and y to obtain an equation f equals x of y. Well, really what this means, remember this is y right here. In the graph, all I had to do was interchange the x and y values, and that will work the same thing in an equation or in a function. So I'm going to switch the x and y values, and this is going to become x equals 2y plus 3. And then I'm going to solve for y in terms of x. So I want to get y all by itself and everything else on the other side. So in this case, I would have to subtract 3 on both sides, and I would have x minus 3 equals 2y, and then I'm going to divide both sides by 2. So basically, y equals x minus 3 over 2. All right, so this right here is my inverse function. It also says that we should check our result, showing that the inverse function of f of x equals x, and the f of the inverse function of x also equals x. So I can do a quick check of that. So if I do f of inverse of x, what we were doing yesterday, I'm going to take the inverse function, which is x minus 3 over 2, and I'm going to plug it into the original function. So this gives me y equals 2 times x minus 3 over 2, and then I'm going to plus 3. Well, if I do order of operations here, I'm going to cancel my 2's, and I'll get x minus 3 plus 3, which just gives me x. And likewise, if I go the other way and I say f inverse of f of x, that should also give me x. So this time I'm going to take f of x, which is 2x plus 3, and put it into my inverse function. So I'm going to have 2x plus 3, and then minus 3 divided by 2. All right, so 2x plus 3 minus 3, those are going to cancel, and I have 2x over 2, which just gives me x. So this just shows me that for this function, this is the inverse function, because the composition of both of those functions, sorry about that, gives us x. In example 8, it says to find the inverse of this rational function when x does not equal 1. All right, and we see that x does not equal 1 because if I put that into my original function, it is undefined. So first thing, let's change our x and y values. Remember, this is y, and then I'm going to rewrite that as x equals 2y plus 1 over y minus 1. And I'm going to solve for y in this case. So I'm going to do some manipulating here. I'm going to multiply both sides by y minus 1. And that will give me, I'm going to distribute here, xy minus x, and on this side they're going to cancel, and that equals 2y plus 1. All right, so when I'm working with two variables and I'm solving for y in this case, I want to get all my y terms, which are these, on the same side. Y's on same side. All right, so that means I'm going to subtract 2y over here and then add x to the other side, because that doesn't have a y. I want all the y terms on this side and all the non-y terms on this side. So this gives me xy minus 2y equals, add x to the side, x plus 1. Now what I want to do is, I notice that both of these terms have a y, so I'm going to factor out the y, and this is x minus 2. Now I'm going to divide both sides by x minus 2 to get x by its, or y by itself. Okay, so that cancels, and I get y equals x plus 1 over x minus 2, and this is the same as the inverse function of x. It also asks us to find the domain and the range for both f and f of the inverse function. So here, the domain is going to be all numbers except for x cannot equal 2. Now, this is the domain of the inverse, so this is going to be the range of f of x. Okay, and the domain for the original function is going to be the range for the original function. So if I just write those both, so the domain for f of x is going to be x cannot equal 1, and that's going to be the range for the inverse function. So the domain for the inverse function, inverse, f inverse of x, the domain is x cannot equal 2, and that's going to be the range for f of x. All right, so example 9 says to find the inverse of f of x. So find the inverse of y, which is f of x, and that equals x squared. So we have the function y equals x squared. And it's giving us a domain. They're just putting restrictions on our domain that x has to be greater than or equal to 0. So if I want to find the inverse function, I'm going to switch x and y. So x becomes x equals y squared. And then I'm going to square root both sides. And then I'm going to have square root of x equals y. So my inverse function is square root of x. And in the domain up here, they said that x is greater than or equal to 0. Now technically when we do the square root in solving an equation, we should have the positive and negative values of x. Okay, so we could have negative values of x here, but they're just telling us we want x values that are greater than or equal to 0. Okay? And that's just so we don't get an imaginary number inside here.